Hi all, welcome back to the video lecture on computer network. So in the video lecture mainly I am going to discuss the reverse address resolution protocol. We have discussed the address resolution protocol in last video lecture. So in the video lecture we will discuss how reverse address resolution protocol will work. So in the last video lecture we have discussed the address resolution protocol. In that scenario we know the logical address, that means the IP address we know, but the sender cannot able to identify the MAC address of the destination. So in that scenario we have done a mapping between the logical address to the physical address using address resolution protocol. In a certain situation, the host which know the physical address, the MAC address they came to know, but they doesn't know the logical address. So in that scenario, the mapping should be performed in a reverse manner. So there should be a mapping between the physical address, that means the MAC address, to the logical address. It should be carried out with the help of a reverse address resolution protocol. For the scenario, we are going to map the MAC address into the physical, that means the logical address. So we already came to know the scenario where we are going to use RARP operation. So we know the MAC address of the machine and we cannot able to identify the logical address, that means the IP address. On that scenario we are going to do the mapping in the case of mapping from physical to logic using RARP protocol. So where we are going to use in that scenario, RARP happen when a disk left station, when it's booted, it can able to find the MAC address of the machine via looking into the NIC, network interface card, can able to get the MAC address of the system. But in that scenario, it cannot able to identify the logical address. Or in a certain situation like if some organization, they doesn't have the enough IP address to provide to all the workstation. So for example, in our college, if 100 systems are connected, the college does not have a capacity to provide 100 IP address. So in that scenario, how they will work? They will get the IP address based upon the request. They will provide initially the MAC address to the server system and wait for some amount of time, and the server system they will allow the IP address to the particular system. So in that scenario, they are going to work out. So how the RARP operation will be carried out? The RARP operation will be carried out with a simple task only. In that there will be a server machine will be there. That server machine contain a static table which contain the details of the mapping between the physical to the logical address available on that particular network. So again I am repeating how RARP operation will be carried out. In the RARP operation, in that there will be a server machine will be available. That server machine containing a static table. The static table contains the information of mapping between the MAC address to the logical address. That means the MAC address to the IP address. They have a mapped one pre-table will be there available in the network. So in that scenario, any device on the network can request for the logical address. So how it will work means there will be a RARP request and there will be RARP response will be there. The RARP request, they are going to request the logical address on the network. So it will be running a client program on the machine. For the client which they are requesting for the IP address will be running a RARP request program. Similarly, there will be a server end will be there. That server end they are going to run the RARP response. So the RARP response will be running on the RARP server program. For the server now, NDA mapping, which all are the mapping possible, then came to know. Based upon the request or reviewing from the client, they will give you the particular response back. So here a diagrammatic representation of RARP operation will be illustrated. For example, there will be 4 hosts A, B, C, D, where D will be act as an RARP server and one router will be there. For example, if A want to send a packet, he came to know the MAC address looking into the NIC card, but he doesn't able to identify his IP address. So in that scenario, from the node A, that means the host A, it will pass a RARP request to the router which they have connected. From the router, they will forward the request to the RARP server. So the node D, the host D, will be act of a RARP server. The RARP server, they are maintaining a static table which containing all the information related to the physical address and logical address available on the network. So once the request from the host A, from the node A, once it coming, it will check on the RARP server. The corresponding physical logical address will be identified, and it will be passed through the router via a RARP response. So from the server, it will pass the response to the router, RARP response passed to the router. From the router, it will again get into the host A. For such scenario, the host A can identify its logical address via a RARP response. So now we have a look on to the topic of RARP disadvantages. There will be two disadvantages they have listed. The first disadvantage, it will be the broadcasting done at the data link layer in the case of RARP. So the broadcast does not pass the boundaries of the network. Within the limit of the network only going to pass the information. So in that scenario, we need to assign a RARP server for each network or a subnet. While we forming a particular a new network or a new subnet, we have to assign a RARP server separately. That will be the drawback in the case of an RARP protocol. So hope you understood where we're going to use the RARP protocol and how it will be work out. So the main key point we have to remember in the case of RARP, it's a mapping from physical to logical. Physical means MAC address to the IP address. So we already came to know that in the last video lecture which all are the essential components while sending a packet. So sending a packet need 4 information: IP address of source, MAC address of source, IP address of destination, MAC address of destination. In that scenario, if any one of the things is missing, we go for a mapping scenario. So just listen to video lecture thoroughly and have a comparison between RARP and ARP protocol. Okay, thank you.